Section 200.3 of the National Electrical Code, or NEC, addresses the critical requirement of preventing solid electrical connections between grounded supply systems and grounded premise wiring systems. This provision aims to safeguard electrical installations and personnel by mitigating potential hazards associated with direct connections between systems with differing grounding characteristics. The core principle is that an ungrounded supply system, such as a utility distribution network that operates without a direct connection to earth, must not be directly and electrically connected to a grounded premise wiring system, which is a system where a specific conductor is intentionally connected to earth. This separation is crucial for several reasons related to fault current management, voltage stability, and overall system safety. A solid electrical connection, as prohibited by Section 200.3, refers to a direct, low-impedance path for current to flow between the ungrounded supply system and the grounded premise wiring system. This type of connection can inadvertently create a hazardous situation if a fault occurs in either system. In an ungrounded system, the absence of a direct ground reference allows the system voltage to float relative to ground. When a fault occurs, such as a line-to-ground fault, the fault current is typically limited to a relatively low level due to the system's inherent impedance. This low fault current may not be sufficient to immediately trip over current protection devices, such as circuit breakers or fuses. However, the entire system voltage will rise with respect to ground until a second fault occurs on a different phase. This phenomenon can create a dangerous condition, as any conductive surface connected to the system can become energized at a significant voltage potential with respect to ground. In contrast, a grounded system has a direct connection to earth, providing a low impedance path for fault current to flow back to the source. When a line-to-ground fault occurs in a grounded system, the fault current is typically much higher than in an ungrounded system. This high fault current quickly activates overcurrent protection devices, isolating the faulted circuit and minimizing the risk of electrical shock or equipment damage. If an ungrounded supply system was solidly connected to a grounded premise wiring system, the characteristics of both systems would be compromised. The grounded system could introduce a ground reference to the ungrounded system, potentially causing unpredictable fault current behavior. This could lead to increased fault currents, nuisance tripping of overcurrent protection devices, and an increased risk of electrical shock. Furthermore, the solid connection could create a circulating ground current path between the two systems, which could result in wasted energy, overheating of conductors, and interference with sensitive electronic equipment. The exception to the prohibition of solid electrical connections in Section 200.3 relates to magnetic coupling through a transformer. A transformer utilizes the principle of electromagnetic induction to transfer electrical energy from one circuit to another without a direct electrical connection. The primary and secondary windings of a transformer are electrically isolated from each other, with energy being transferred through a magnetic field. This isolation is crucial for maintaining the separation between the ungrounded supply system and the grounded premise wiring system. Because there is no direct electrical path, the transformer effectively prevents the transfer of ground faults or circulating ground currents between the two systems. This allows the grounded premise wiring system to function properly, providing a safe and reliable ground reference for fault current protection. The use of a transformer to isolate an ungrounded supply system from a grounded premise wiring system is a common practice in various applications. For example, in some industrial facilities, an ungrounded delta system may be used for the main power distribution. To supply power to individual loads or branch circuits that require a grounded neutral, a separately derived system is created using a transformer. The transformer isolates the ungrounded delta system from the grounded system, allowing the grounded system to be properly grounded and bonded according to the NEC requirements. The grounded conductor, or neutral, of the separately derived system is connected to a grounding electrode conductor, which in turn is connected to a grounding electrode system such as a ground rod or a building steel. This grounding system provides a lower impedance path for fault current to flow back to the transformer, ensuring that overcurrent protection devices will operate quickly and effectively in the event of a fault. In addition to providing electrical isolation, transformers can also be used to step down or step up voltage levels. This is particularly useful when the voltage of the ungrounded supply system does not match the voltage requirements of the premise wiring system. For example, an ungrounded 480 volts delta system may be stepped down to a grounded 208 volts/120 volts Y system using a transformer. The 208 volts/120 volts system can then be used to supply power to lighting receptacles and other equipment that require a lower voltage. The NEC provides specific requirements for grounding and bonding separately derived systems in section 250.30. These requirements include the size of the grounding electrode conductor, the location of the grounding electrode, and the bonding of the transformer enclosure to the grounding system. It is essential to follow these requirements carefully to ensure that the separately derived system is properly grounded and bonded, and that the safety of the electrical installation is maintained. In summary, Section 200.3 of the NEC prohibits solid electrical connections between ungrounded supply systems and grounded premise wiring systems to prevent potential hazards associated with fault current management and voltage stability. Magnetic coupling through a transformer is not considered a solid electrical connection, as it provides electrical isolation between the two systems. This allows for the safe and reliable use of grounded premise wiring systems in conjunction with ungrounded supply systems. When designing and installing electrical systems, it is crucial to carefully consider the grounding requirements of the NEC to ensure the safety of personnel and equipment.